Hi, thanks for the introduction. My name is Aaron Parecki. I'm going to give an introduction to OAuth-2. I would like to start with a bit of history on why OAuth-2 is here in the first place, and how did we get here. Something that you may remember before OAuth, also known as the Dark Ages, if, for example, you wanted to post something to Twitter from a third-party app, you would actually go and log in with your username and password to that app. You give your Twitter username and password to some random site that would make you register for a contest or something. And obviously this is bad for a number of reasons and led to a lot of spam on a number of services. This is in general, a terrible pattern to follow. You're giving away your password to the service. The app can store it. There's nothing you can do to prevent that. And you also give the app complete access to your account on that service, when all you really wanted to do was post a tweet or follow somebody. And there's no way to revoke access to this other app except by changing your password. And then, of course, everything you've registered and connected that way would be revoked as well. And the other consideration is that if you log into an app and the app is compromised in some way, they have to store your password in plain text because they have to log into Twitter for you, and you would then have your Twitter password exposed. And I'm pointing out Twitter here because it was a really common example, but it was by no means the only one that was following this pattern. So a number of services recognize the need for a solution to this and a way to avoid doing password logins to other sites. So a lot of services developed their own solutions that were similar but slightly different from OAuth-1. And each implementation by each service ended up being slightly different, and certainly not compatible, but they all accomplished approximately the same goals. You had Flickr with Flickr Auth. You had to get a FROB and exchange the FROB for a token. Google had something called Auth-Sub. Facebook signed the requests with MD5 hashes. Yahoo had BBAuth, which was browser-based auth. Everybody was trying to accomplish the same thing and doing it completely on their own, and it was a big mess, and everybody was reinventing the wheel. Blaine Cook in 2007 said, we want something like Flickr Auth, Google Auth-Sub, Yahoo BBAuth, but published as an open standard, common server and common client libraries. It's a pretty big goal, but people recognize the need for this. So then what you had was OAuth-1. Several people came together and decided to formalize the spec and actually work on a common standard. And then you get this with Twitter, where you're by now completely accustomed to this flow. You see a sign in with Twitter button on some site. You get the authorization screen that says this wants to access your account. It'll be able to read tweets from your timeline. There's a big authorize app button, and as soon as you do that, the app is authorized. It can access your account without having to give it your password. So that's great. A lot of services implemented this. Twitter, one of the most visible probably at the time. The only problem was that it turns out it was actually kind of difficult for developers to actually implement this on their own, both from the client side and certainly from the server side. The main hang-up people had was dealing with the signatures. So you had to calculate the signature as a combination of all of the body, the payload of the request, and the host name and timestamps and your consumer key, your consumer secret, and to sort them in the right order, calculate a signature, and attach that with your payload as well. And it was certainly possible to do. A lot of people figured it out, but it left a lot of people really confused. Certainly, if you wanted to implement an OAuth-1 server, you had to completely understand that algorithm from the ground up and understand how to implement it and consume other people's requests. So OAuth-2 saw this as a problem and decided to address it. Basically, the main difference is that instead of dealing with signatures as the only layer of security, everything goes over SSL, over HTTPS. So you get all of the inherent security that's already present in that HTTPS connection without having to reinvent it. You get the certificates, it's encrypted on the line. You also get to verify the host with a certificate they present. And that all of a sudden became much easier to consume and to develop for. So some of the current implementers of OAuth-2, there's actually a big host of them. And it's great because it's much easier to consume this now from the developer side, as well as write servers for it. So I'm going to give you an intro to the OAuth-2 spec now. You can go to OAuth.net/2 to get an intro and read the spec as well and find the actual document that I'm referencing here. You may notice that if you do click through to the spec, you actually see 29 different versions. And you may say, why is this? Well, turns out OAuth-2 is not actually finalized yet. So it's still in draft. It's actually in the process of being put through the process to, finish it off, put a final version number on it. In the meantime, we've got all these drafts, and I've had all of these drafts for several years. I did a quick survey of some services that implement OAuth-2 servers, and it turns out that most of them have settled on draft 10. And the reason for that is that OAuth-2 draft 10 was the current published draft for most of summer 2010, and there weren't any changes made through most of the summer. So that's the only real reason. But what ends up happening is that over the next few drafts, a lot of changes have been made, and there are now some things that are quite different in the final version of the spec than what is actually implemented by many servers. The draft 29 is the latest currently. The last several drafts have only been minor copy editing. Not much functionally has changed for several versions back now. The draft that you see, 29, right now is expected to be the one that is actually going to be the final version. Probably a few more minor changes to the wording and terminology of things, but functionally that's what you're going to see as the final version. So how does it work? I'm going to give you a few definitions of things that we'll need to know to talk about this in more detail. So there are typically 3 or 4 parties involved. There's the user, called the resource owner. There's the API, which is called the resource server, and that's typically what you think of as the API. The authorization server is often the same as the API server. Most services just have the same server for them, but something like bigger organizations like Google, Yahoo, they tend to separate their authorization servers. And then the client, which is the third-party application. So really you've got the user, the service, and the client. So let's talk about some of the use cases for different ways we can use OAuth-2. Web server apps are typically what you think of when you think of a OAuth flow. This is where you are logging into some web app, whether it's like project management software or a photo editing tool, trying to access your Flickr photos or something. There's a server-side component. you log in, it does some stuff, and it keeps your data on their servers. Their servers are accessing your account. Browser-based apps, on the other hand, the entire app is running in your browser, and there's no server-side backend component to it. There aren't too many of these out in the wild yet. There's a few. Facebook has done a pretty good job of making this flow available, so there's some Facebook apps. Username and password access. This is totally going against the pattern of OAuth-2 and OAuth in general, but in some cases it's acceptable to use a username and password authentication. For example, if you're writing your own app using your API. Application access is when there's this client application that just needs to get access to something in the API. Probably it's something under their own control. Facebook calls it application access tokens. You can request an application access token from Facebook. And then finally, I'm going to talk about mobile apps, where you need a mobile app to sign into some third-party API to use OAuth there. And there's a couple of different considerations when you're doing a mobile app that you need to keep in mind. So if you've done any reading about OAuth in the past, you've probably seen diagrams like this. So this is from Facebook. And these are okay. You can step through them and understand what's going on. But personally, I like to see real examples of code working. So I'm going to walk through some code examples with you guys. We'll start with web server apps. In OAuth terminology, this is called the authorization code grant. So the first thing you do is you create a login link. I'm going to use Facebook as an example, with the caveat that Facebook doesn't always implement things exactly as written in the spec, because they were a leader in the OAuth spec, and as such things have changed since they've put them into production. So first thing we do is we create a login link. There's a couple different components to this I'm going to point out. The first is the response type. The response type code indicates to the server that we're doing the authorization code grant type. You also put in your client ID, which is your app's unique ID that you've registered beforehand. This, obviously, since it's in the login URL, is not considered private information. This is public information that anybody can get to for your app. The next part of the URL is the redirect URI, where this is the URL you want Facebook to return your users to after authorization is complete. And the last component is scope. In this example, I've set it to email, which is a way of letting Facebook know other parts of the user's account that you want to be able to access. So you create this login link, they click it, the user ends up getting taken to this authorization page. And this is on Facebook.com. And what they see here is the application name, the icon, short description, and what it wants to do with your account. When you click the Go to App button, Facebook says, great, it's approved, and we're going to take the visitor back to your redirect URI. When they redirect the visitors to your site, there's the code. In my example here, I have it auth code here. That will be the authorization code that you will use for the next step. The next step is exchanging the code for an access token. This is making a simple POST request to Facebook Graph API. The grant type is authorization code you got from the query string beforehand. You pass the same redirect URI, your client ID, your client secret. Assuming all goes well, you end up getting an access token in response. So that's the authorization code grant type. I'm going to go through the next flow as well. This is for browser-based apps. This will be implicit grant. So here you'll see the login link looks slightly different. The response type instead is token, and the client ID and the redirect URI are the same as before. When the visitors click this login link, they see the same authorization page. However, when they click it, they go back to your website, in this case example.com, but notice instead of a code, the access token is just right there. So at this point you're done, and there's no exchanging the code for an access token. You just have it. The trick is that the access token is in the fragment. There's the hash sign of the URL. So this is typically used to for JavaScript-based apps to pull that token out of the URI and use it from here out. So browser-based apps, this is called the implicit grant type. The neat thing is there's no server-side code needed because nowhere in this process did you use the client secret. Obviously, you can't put the client secret in JavaScript source code because anybody could see it and impersonate your app after that point. So in this example, using the implicit grant type, the JavaScript code is able to just get the access token directly, and then the browser can start making API requests using that access token. All right, I'm going to talk about the username and password grant now. This is in the OAuth spec, you'll see this listed under the password grant. Password grant is really only appropriate for trusted clients. What I mean by trusted clients is probably only your own apps for your service. You really don't want to encourage third-party apps to use the password grant type because it breaks the entire security model of using the authorization code and not exposing the password. Twitter recognized this as a problem early on, and they developed something they called OAuth, which is essentially the same as this password grant, and the password grant was in fact modeled after it based on that use case. But if you notice that in the Twitter documentation, you have to get explicit permission to use OAuth because you'll end up collecting usernames and passwords for Twitter users, which is less than ideal. So a lot of times this is used for mobile apps because, or especially your own mobile apps, where you just want to present a login form, and if people are logging into your own app for your own service, they expect to see a username and password login. So it's appropriate in this case. Here's the post request used to do this. Grant type is password. You pass in the username and password, client ID, client secret, and you get back the access token. Really straightforward. There's no web redirects, nothing. It's just, here's a password, give me back an access token. Application access is for if your application has some sort of resources, like maybe it wants to get a list of users that have authorized access to itself. It's not accessing another user's information, it's just accessing its own information. So that's the client credentials grant. Again, there's no web flows. This is for server-to-server communication. So in this case, the grant type is client credentials, and there's nothing else. It's just your client ID and client secret, you get back an access token. So when we start getting into mobile apps, it gets a little bit trickier because there's a few reasons. Mobile apps, there have been a couple of cases of this where the mobile apps have been decompiled and people have discovered the Twitter app's client secret. Obviously, if you have another app's client secret, you can pretend to be them and you can do all sorts of nasty things. So because of that, it was decided that the mobile app should never store the client secret for the same reason that browser-based apps should not store the client secret. So we have to work around that. Oftentimes, the implicit grant is used for mobile apps. Now, I'll walk you through an example here of writing an app that lets you log in through Facebook on the phone. So Facebook's actually developed a great iPhone SDK to make this whole process really easy, but I'm going to step through the inner workings of it anyway. So you make your login link, and it's very similar to what you do on the web, except when you click it, it actually opens up the Facebook app. Visitors get taken to the Facebook authorization screen in the Facebook app on your phone. Very similar to the web view. They have a big OK button in the corner. When they click OK, they get redirected back to your application. The way they do that is on iPhone, you have the ability to register a custom protocol. So instead of HTTP here, we have FB and some numbers. The numbers are the Facebook app ID that you registered with Facebook beforehand. So they redirect your application they redirect the visitor on the phone to this custom protocol, and then again, you notice the access token is in the fragment, just like in the browser-based auth. At this point, the mobile app can pull the access token out of the fragment and store it and use that from here on out. You get taken into the app, and it works great. So for mobile apps, you use the implicit grant type. There's no server-side code again. You don't use the client secret because you can't protect it. And the mobile app, after that point, starts making API requests directly. The next section is about accessing resources. I think I'm going to pause here and take a couple questions about grant types before I continue on too much farther. So OAuth is a thing that Twitter developed, and it addressed the problem of people don't really like to be redirected to web browsers in mobile apps. So often people wanted a way to log in with someone's username and password, but ultimately that's not a very safe practice. So Twitter has heavily restricted who can use OAuth. They do use it internally for their own apps because there's not really a security issue inherent in putting your Twitter password into a Twitter app. It's a question of how to get the link to facebook.com/dialog. How do you know what URL to direct people to? You'll typically find that by just reading the documentation of the service. And there's no mechanism for programmatic discovery of this currently. That was decided that it was out of scope of the initial draft of OAuth. So it's possible that we'll see some sort of automatic discovery of these URLs later, but in the meantime, you just have to go read the documentation for the service you're trying to use. Unfortunately, this does mean that you can't just literally write one OAuth client and use it against every OAuth server. That is the one downside. I'm going to go back and point out the differences between the response type for browser-based auth and JavaScript auth. Sorry, I'm pulling up the slide. Here's the first example I showed where you have response type as code. This indicates to Facebook that you want Facebook to return an authorization code, not an access token. In the browser-based example, the response type is actually token, indicating that you want Facebook to return an access token. to the browser directly instead of an auth code, skipping the authorization code grant completely. Another question is, the password grant appropriate for partners who you authorize to access your data? It's a tough call. I have to say it's up to the service to decide who to allow password grant to use. But keep in mind that as this OAuth pattern starts to be more and more prevalent, people are going to be less and less willing to put their password into anything except something that is branded with the service they're logging into. So if anything else asks for your Facebook password, for example, it's not legitimate. There is no reason to put your Facebook password in anywhere except Facebook. And that is a good pattern to follow. It prevents a lot of attacks, a lot of vulnerabilities, and protects users quite a bit. So sticking to that pattern is a good idea. So the password grant, in general, should really only be used for your own applications. You know, if you're making your website, if you have an API and a website separately and you're making your website and people can log into it, it's a good, you know, for a number of reasons, to make your website use your own API, eat your own dog food, and that's a great use for the password grant type. Your own website or your own app talking to your API. All right, so I went through the four of the grant types. At the end of all of these, you end up with an access token. So now you have an access token. Now what do you do? The access token is the thing you actually use to start talking to the API on behalf of the user. So now you can start making requests. There are two different ways usually. APIs don't have to support both. They can support one or the other. Two different ways to use the access token. You can pass it in authorization header, which is the first example on this slide. So you say authorization bearer and the access token. The other way is by passing it in the query string. So you can just, you can just run it from curl really easily just by copying that line into curl. Eventually, the access token will expire. And after it expires, you need a new access token. If you noticed in a couple of the examples earlier, the response that contained an access token also contained a refresh token. The refresh token is your key back into the user's account. And this will let you exchange the refresh token for a new access token. Very similar to the other post requests, the grant type in this case is refresh token. And you pass in the token, and you get back the access token and possibly a new refresh token. The reason people use refresh tokens is they'll tend to use very short-lived access tokens, anywhere from 5 minutes to an hour, and that effectively limits the damage that somebody can do if the access token is exposed, because it will stop working after an hour, and then they have no way to get a new one back. A couple things to keep in mind. So I've only showed you the bearer token example. There's also MAC tokens, which is it's a cryptographic solution to access tokens. So you may have noticed that if you have an access token, that's all it takes to start accessing someone's account. You don't need the client secret anymore. Once you get the bearer token, you can start making requests. As such, the only way this is at all secure is by using HTTPS and having everything going over SSL, because the request itself is not signed. Because of this, you have to make sure that you always use HTTPS. Always validate the certificates. Don't turn off the certificate checking. Make sure you're storing the tokens appropriately. If it's on a mobile device, store it in an encrypted storage available on the phone. If it's in the browser, use some sort of secure storage in the browser. don't just store them in plain text cookies. And certainly don't put them in page links and page URLs, because things tend to cache them, proxies will cache them along the way, browsers will cache them, and you don't want access tokens floating around. Those are the security recommendations or downsides to using Vera tokens. MAC tokens are a cryptographic verification of the token, where this is more like what you've seen in OAuth-1. And the reason this exists is because a lot of people said, Vera tokens are not secure enough for my needs. I really do want clients to sign the request so that I can be sure that it is only the client that has sent the request. Similar to the OAuth-1 signature method, it's not exactly the same, but same idea where you take the payload body, you sign it with your client secret, and you include that as the authorization header. This ends up being, in practice, a little more difficult to implement because you have to do a bit of crypto. But chances are, if there's a client library for a service, it will be handled by that library anyway, so you won't have to really think about it. Client libraries also should handle things like refreshing access tokens when they expire, so that you don't have to worry about that either. Which also means that if you're writing an OAuth-2 client library, you should be doing these things as well. The next thing I'm going to talk about is this idea of scope. And I touched on it a little bit earlier in my first example of Facebook logins. Scope is a way to limit access to resources. So obviously with the password grant type, if you give a service your password, they can do anything they want to your account, including changing your password and lock you out. That's not good. The way this came up was with Twitter apps. There was, before this version of the auth screen, if you authorize a Twitter app, what would happen is it could do things like read your direct messages, or change your profile picture, do whatever it wanted. And people realized after a while that, oh wait, maybe we shouldn't expose the user's direct messages over the Twitter API unless they explicitly allow it. People didn't really think about it. So the new Twitter auth screen is this, and you see a list of things that the app will be able to do and a list of things that the app will not be able to do. This is a pretty good way of indicating this to the user. So scope in OAuth-2 is, it was created to limit access by third parties to parts of the account. You usually indicate the scopes by a list of strings. Some services use comma-separated strings instead because at one point the OAuth-2 spec said commas were a separator. The spec itself does not define any values. It's left up to the implementer of the service. So if Facebook defines their list of scopes, GitHub defines their own list of scopes. You can pass more than one scope value in. The order doesn't matter, and each will just add the scope. So I'm going to give us some examples here. With Facebook, you have, here's the scope is email and read stream. And then the way Facebook surfaces this to the user is they have this list of things that the app wants to be able to do. Access my basic information, send me email, and access posts in my news feed. Facebook has defined a whole bunch of other scopes. If you go to the Facebook documentation for OAuth, you can actually find this list. It's twice as long, and there's like 3 of these lists. You can separate access to events, groups, whether or not they can see their birthday. So Facebook's done a pretty good job of segmenting access so that apps only get the bare minimum amount of information that they need in order to function. GitHub has defined a separate list of scopes, much smaller list, but it's also very easy to understand. Basic access would be just read-write access to profile info. If you include the public repo scope, apps can then have read and write access to public repositories. If you pass the repo scope, then the app can see private repositories. It was a great idea to separate delete repo so that apps that you authorize can't just delete any repository on your account. You have to explicitly allow the app to delete it. And then there's a separate one for GIST where it can write GIST on your behalf. This is an example of a proposed UI for Twitter by Ben Ward. This was a couple of versions of Twitter back ago, but the idea here was that the app can have the list of scopes they want to do, and the user can decide whether or not to allow a specific one. So Ben Ward wrote a great post about explaining this this screen and motivations for things. The URL is below. I would encourage you to take a look at it. But if you notice here, the scopes are read, tweets, update my profile, and post tweets using my account. And there's a checkbox under that post tweets so that if you really didn't want the app to post for you, you could uncheck it. And then you'd still be able to use the app for whatever else it did. It just wouldn't be able to post. And the reason this went around is because there was a huge rush of these Twitter apps that were spreading virally by tricking people into clicking on them and posting tweets to all their friends as their friends would click on them. Twitter's done a really good job of improving that screen now as well. Doesn't look quite like this, but it does a very good job of explicitly saying what the app can and can't do. So before I go too much farther into implementing an OAuth server, are there any other questions about scopes or grant types or any of the use cases as far as mobile apps, browser-based apps? All right, so OAuth-2 servers. If you're talking about implementing an OAuth-2 server, then here's a couple. So I'm just going to catch up on these. All right, so can you give an example of usage of refresh token? Let me go back to that slide. I'm going to give you two examples here. So with the traditional web flow, where you get the authorization code, here it is, and you get back an access token. Here's the authorization code grant. You make the request. The response is the access token. But you also notice here there's a refresh token. The refresh token expires in value of 3,600. So this is saying this access token will only work for an hour. After that, it's going to expire. Then you need to use the refresh token. You'll get this expire token error at some point after that hour is up. So you need to get new access tokens. Here's an example of using the refresh token. You set the grant type to refresh token. You include the refresh token. You also include your app's client ID and secret. And then you get a response that looks very similar to the first one with the new access token. Question is it common to create your own auth token scheme? For example, to encrypt data in the auth token. I would say certainly that is something that you can do. Basically, the OAuth spec doesn't require your tokens to have any specific format, and it tells services that they should not try to inspect the contents of an access token. So if you look at Facebook access tokens, you'll see a bunch of segments, and you can see some things that look like separators. I think you can even see your Facebook ID in it. I don't remember if that's still the case. So they're doing something with encoding some information in the token. It's pretty common to encode scope in the token, for example, so that you don't have to look up the token in a database. The main advantage of encoding information in the access token is to avoid having a giant pile of tokens in a database that you have to look up every time. So that will get you a way to, using nothing but the token, figure out what it can do. You can encode the expiration date in there as well. Of course, if you do that, you have to make sure it's encrypted and signed with something that only your app knows, so that nobody else can inspect or tamper with it. Question about Facebook using refresh tokens. I believe they used to at some point. I don't think they do anymore. They also recently deprecated what they used to call offline access, which was the ability for an app to access an account without the user being in front of their computer. They did something to replace it, but yeah, they've been changing things around a lot. So Facebook is sort of an anomaly whenever we talk about OAuth-2, because they've been around for so long, and they were one of the first people to actually implement it, that it doesn't always reflect the latest specs, and they've at some points made decisions that didn't make it into the spec either. All right, I'm going to continue on to the OAuth server section. So implementing an OAuth server, there are a couple of client libraries that will help you, server libraries that will help you with this. If you go to OAuth.net/2, on that page there's a couple of links to, there's a PHP one and I believe a Ruby one. And they've done a lot of the work of figuring out how to support all the different grant types and doing all the security appropriate for each. They usually give you hooks into the storage so that you can write your own storage engine for tokens or however you want to deal with that. So it's probably a good idea, if there's a library in your language, to at least take a look at it to understand what they're doing, and work from that as a starting point. So at this point, you should probably just implement the latest draft 29, because that's what's going to turn into the final version. If you have a good reason to go back to draft 10 because it's the most widely implemented draft that's out in the wild, you can do that as well. But whatever you pick, actually go and read the spec. It's not as bad as it sounds. I know specs can be scary, but it's written in a way where it's meant to be read by implementers of servers. Every word is very carefully chosen. Every word has probably been debated at least 2 or 3 times on the mailing list. And there's a lot of good information there. But ultimately, in many cases, the implementations are going to be slightly different anyway, because a lot of cases the spec leaves choices to the implementer. So that is the reason that, for example, Facebook and GitHub and Google's OAuth APIs aren't entirely compatible, and you still have to end up writing some application-specific code. So we've also made some choices about which things to support, whether to support bearer tokens or MAC tokens or both, whether to support access tokens in query strings or only in headers. But whatever you decide, just make sure that you've considered security implications of the choices. The other thing to consider is defining your scopes for your service. So you choose what grant types to support. Maybe you don't support passwords, you choose what kind of tokens, and you define your scopes. The scopes on your service, think about what you might want to offer to people. Don't overcomplicate it. I think Facebook has gone a little bit overboard, although it's very fine-grained, and they're also an exception in a lot of cases because they have so many users. GitHub's done a great job of making it simple to understand and simple for users. A good starting point is just read versus write. Allow access tokens to be read-only, or allow people to authorize apps that can write and separate those. So for mobile applications, there's two different ways people have normally gone about implementing mobile apps. You can either, if it is a native app for the service, like on Facebook, for example, Facebook has a native app. The best way to do it is to use the app to do the authorization rather than using a web browser. If there's no native app on the phone, you can still open up a mobile web browser on the phone and do the redirects the same way. The experience ends up being slightly less nice just because when the app opens, it's completely branded with a service, and it's obvious that it's that service and there's no phishing going on. But you certainly can use, for example, native Safari on iPhone. You can also choose whether to support auth code or implicit grant type for mobile authentication. But in both cases, you don't use the client secret. And this is talked about in the authorization code grant type section, where if you're using the auth code with something like a phone that can't keep a secret, just don't use the secret and don't authenticate that. So staying involved, how do you keep up to date on all this information? There's a couple of ways. There's a mailing list, the official mailing list of the spec. People talk about OAuth. You'll see how the spec changes, and people argue about OAuth a lot as well. It's kind of fun to watch. There's a lot of good information there. Now that there's less raging debates about what to include in the spec, it's getting more formalized, more solidified. A lot of the posts on there now are people actually asking questions about implementation and implementing servers, their own servers, and how to do various things and what to consider. So it's a great way to see what people are coming up against when actually starting to use this. There's also the OAuth.net website, which is started with OAuth 1, and now there's some OAuth 2 information there as well. This is OAuth.net. The source code for the website is actually available on GitHub, so feel free to correct anything you see there. You can fork the repository, send me a pull request. I like to collect things like lists of client libraries or lists of current implementers of servers. OAuth is a very community-driven thing, so if you're at all interested, I definitely encourage you to stay involved with it and contribute as much as you can. Write as much code as you feel like, make it available to people, talk about reasons why you think something is awkward, because this is also ever-evolving, and chances are other people will have the same problems that you encounter. So github.com/AaronPK/OAuth.net. That's the source code to the site. You can edit it right on GitHub. You can copy it onto your computer to edit and push some changes back to me, and I'll make sure they get published. That concludes my presentation. You can also see more info, and you can get these slides on my site, aaron.pk/OAuth2 is the short URL. You can visit me at aaronparecki.com, and I'm AaronPK on Twitter and GitHub. So thanks very much for attending, and if there are any more questions, feel free to type them into the chat window, and I'll hopefully see them here.
Great. Thank you, Aaron, for an amazing webcast today. We do have several questions that have come in. Are you able in the Q&A box there to click your refresh button, and that should give you a fresh load?
Great. Okay, there they are. Yep, let me go back to these really quick. This question, if I wanted to install an internal authorization server, which do you recommend? There are very few productized versions of these as far as I know. There's a PHP and a Ruby OAuth APIs, server APIs, linked on the OAuth.net website. I don't think there's a Python one yet, and I'm not actually sure if there's a Java one. If you do know of any of them, please feel free to add them to the list. There's no, these are mostly APIs though, and they tend to leave the actual browser UI and authorization screen up to you as the implementer because you would want it to be branded with your own service and probably not look like somebody else's service. On the mobile app slide, let me go pull that up. The question is about no server-side code for the mobile app. And yeah, the way that most mobile apps end up working is once the app gets the access token, the app makes API requests to the service. So in my example of the Everyday City app, this app, you log in with Facebook, and it just runs in the background, and when you change cities, it'll post your current city to Facebook as a nice little wall post with the map. Basically, the phone makes the API request to Facebook. So it uses the access token it had, and it talks to Facebook. There's not a server backend component to this. You can use the auth code as well as the implicit grant type on mobile apps, but when you're using the auth code, you just don't include the client secret because you can't put the secret into the app without it, and it still have it be secure. Okay, another question is, OAuth always implemented as part of a web server, or are there leaner implementations available? Typically, especially smaller services will integrate their OAuth along with their API, their actual service API. So they'll end up looking the same. They'll be the same on the same domain. They'll have a similar URL structure. It is certainly possible to separate them completely. Most of the larger services where they have multiple components like Google and Yahoo and MSN, Google has half a dozen or more like 2 dozen different things that you can opt into. So they have a central auth server. But yeah, OAuth itself is always in the context of some sort of web thing. It's either a web browser or a phone talking to an API. Because you're always talking about granting third-party access to some user's information. The OAuth-2 spec itself, the question is about how far away is OAuth-2 from being ratified. Is it worth buying a book now if the final spec is going to be different? The spec itself, the actual inner workings of things like query names, parameters, and terminology, that's been relatively stable now for the last several drafts and several months. Basically, the last changes that have been done are things like security recommendations and updating the intro wording to the spec to give people a little better idea of like motivations behind things. But not much has functionally changed in the last several months, which is great. It's in the process of actually being finalized and published as a final spec. I would say it's certainly fine to start using it now. There's a ton of people implementing OAuth-2 on the server and client side. Buying a book on it is probably going to be just fine because there's not going to be much that functionally changes between now and when it's published. And also, you can get updates to the electronic book if there is a book update to a book that's released. A couple questions about some languages, language code, Node.js and Java. I'm not super familiar with that side of things. I suspect that there's some code being developed, at least on the client side, probably on the server side for Node.js and Java. I encourage you to, if you do find one, add it to the website so that I can publish it back on the site again. But I don't know of any off the top of my head. And then another question, is it good practice to request a refresh token before the time the token is up? Like changing the parking meter 5 minutes before it expires. I don't think there's anything wrong with that at all. I know a lot of people do it. A lot of people will treat the expires in value that comes back to the token as a rough estimate and not exact to avoid getting an expired token error. There won't really be any harm in doing it. Anything else? Refresh again. I think that's it. Sorry, somehow I got logged out of the group chat, so I can't actually see the group chat window here. But if there's any questions, they should pop up in my Q&A window here.
Sure, let me take a peek here for you, see if there's any more. We do have a final question that came in from John, and John would like to know, can you talk about how OAuth-2 would handle authorizations for anonymous users? For instance, having an application call a web service not in the context of a specific user.
Sure. So anonymous users, there's two ways you could handle that. I talked briefly about the application access token idea, which is the client credentials grant. And the purpose for that is if an application has prearranged access to some user accounts, the application can use the client credentials grant to gain access to those again. That's all the spec says about client credentials. So basically that gives you a hook to use that for the purpose of dealing with anonymous users. The way I've dealt with that before is, let's say I'm making a mobile app and I want it to just open up. As soon as people open the app, I want it to just start working. And I don't want them to have to log in or sign up. So the first thing the app does is it goes and makes a new anonymous user account. And there's no identifying information in that at all. It just makes up a unique ID and it makes a new account. It gets back an access token. The application that made that user account, it gets linked to that application so that if the application later wants to go and, for example, list all the user accounts it made, it can use the client credentials grant to get a token that can make that query. It could then also pass in the user ID of one of the users to get that user's profile information. All that will be done with the client credentials grant, where it's actually it's the application requesting information about users it made, and the users themselves don't have any way to log in, so there's no authorization that can be done. The authorization is implied by the fact that the application made the user. And this is, of course, a slightly more advanced usage of an OAuth server, or certainly something you only deal with if you're implementing your own server API. So you won't run into that situation if you're just talking to things like Facebook and Google.
Great. Thank you very much, Aaron. I'm not seeing any additional questions. So with that, we are going to say, folks, a really big thank you to Aaron for an outstanding webcast today, for sharing so much knowledge and information and his expertise with us. We thank all of you that attended the event and hope you benefited from it. We would like to let you all know we did post several comments in the chat to you all with a link to Aaron's book. Aaron's book is going to be released here in 2013. You can pre-order it now. You know it's going to be a hot seller, lots of information people need on OAuth. So take a look at that. Please pre-order it. We've put a code in there that can save you some money for doing it. Also like to let you know Aaron is doing another webcast for us on July 27th. We pushed a link out as well so you can register for it. All our webcasts are free, and as you know, lots of good information for you. Thank you again, Aaron. Thank you, everyone. This will conclude today's webcast. Goodbye, everybody.